Section 2.3 is on long division and synthetic division, also called synthetic substitution. I'm going to do an example of each and then a couple of places where one might be useful over the other. Okay, so for example one, we're going to do long division. Okay, I'm going to go ahead and set it up like a long division problem. Okay, so I'm going to put the dividend in here. Okay, and I'm dividing by x squared plus 1. So that's going to go out here on the little box. Okay, let's see. And depending on how you learned this previously, I normally just look at the first term and the first term and think, what do I multiply this term by? So it will equal this term. So if I have x squared, what do I multiply that by to get 5x to the third? To get x squared times 5x will give me 5x to the third. I like to line it up under the column with the like terms. It's not necessary. It just gives me a reminder of when I've gotten to the remainder. Okay, now I'm going to multiply the 5x by the x squared plus 1. Make sure you distribute and also line up the like terms. Let's see, 5x times x squared is 5x to the third. 5x times 1 is 5x, so I'm going to line it under the like terms. Okay, the one thing about long division is you need to remember that when you're doing long division, you subtract as you go down. And how you denote that is up to you, but you just need to remember that you are subtracting. So 5x to the third minus 5x to the third is nothing. 3x to the second minus nothing is 3x to the second. And then 2x minus 5x is minus 3x. And I'm going to go ahead and bring down that minus 5 at the end. Okay, now I'm going to go through the process again. Okay, let me look. I have an x squared here. I want to think about what I multiply x squared by to get 3x to the second power. So that's going to be x squared times 3, positive 3. So I'm going to put a positive 3. I'm going to multiply this out again. This 3 times this entire x squared plus 1. Distribute, line it up under the like terms. So 3 times x squared plus 1 is 3x squared plus 3. Okay, and you don't need to put these parentheses and subtraction, but you need to remember that you are subtracting when you do long division. Okay, so if I subtract 3x squared minus 3x squared cancels. Minus 3x stays the same, and then I have a minus 5 minus 3. Minus 5 minus 3 is minus 8. Okay, this leftover amount at the bottom, this is my remainder. And when we write our answer, we typically write it as a mixed fraction. Okay, so when we divided, we got 5x plus 3. So I'm going to write 5x plus 3. Okay, and then I have a remainder of negative 3x minus 8. So one way to write this would be that I have negative 3x minus 8 over x squared plus 1. Okay, that's a good answer like this. Some people see the minus in front of the 3x and they really want to make this look a little cleaner, which is great. Just be careful when you do it. So this will still be 5x plus 3. If you would like the minus to be out here, that's fine. But keep in mind that you're kind of distributing the minus sign when it's in front of the fraction. So this will have to be positive 3x and positive 8 because that really means I'm subtracting 3x and I'm subtracting 8. So these are equivalent answers. The second one's a little nicer, but the first one's just as correct. The second example is going to use synthetic division to divide 8x to the third minus 22x squared minus 9x plus 7 divided by x minus 3. Synthetic works best when you're dividing by a linear factor. So I'm dividing by x minus 3. This is degree 1. That's linear. The previous one was x squared plus 1. It was degree 2. That one's better to use long division to divide. Okay, synthetic division is kind of how a computer thinks about it when it divides. It thinks of numbers. It doesn't know what the letters are or the variables. Okay, so I'm dividing by x minus 3. So I actually want to think of what value of x would make this 0. Okay, so if I were solving this, I would think that x equals to 3. And I'm going to use the 3 to set up my synthetic. Okay, now depending on how you were taught to set this up, it looks something like this. Okay, along the top row, you put the coefficients of the polynomial in decreasing order. Don't leave any off. If there's a missing term, you put a 0. So it's 8x to the third minus 22x squared minus 9x plus 7. Okay, I like to put a little dashed line along the last column just because it tells me where the remainder is. You don't have to, but it does help me keep track. Okay, first thing I do, bring down the first term or the first coefficient. So that's going to be 8. Okay, now I'm going to multiply. I multiply this 3 by this 8, and then the answer goes here. So 3 times 8 is 24. Okay, then I add the column down. Negative 22 plus 24 is 2. And then I repeat that step again. Now I do the 3 times this number. The 3 times the 2 is 6. And then again, I'm adding down, combining these terms. Negative 3. Then I'm going to repeat 3 times negative 3 is negative 9. 7 minus 9 is negative 2. So I've gotten a list of numbers. I need to go back and retranslate this into a polynomial. Okay, because I put the dashed line, that helps remind me that this last term represents the remainder. Okay, and then each column represents kind of an increasing value. So this is the constant, this is the linear, this is the quadratic. If I kept going, this would be the cubic. So now I'm going to rewrite this as a polynomial. So this was the quadratic, the linear, the constant, and then I had the remainder. My remainder was minus 2 over, what did I divide by? X minus 3. And if you did long division, you would get the same result. For example 3, we're going to use synthetic division to evaluate f of x equals 5x to the third plus 8x minus 7 for the indicated values. Synthetic division is sometimes called synthetic substitution because if you want to evaluate a value, if you use synthetic division or substitution, the remainder is going to represent that value, which is actually convenient sometimes. So I want to figure out what f of 2 is. Okay, since this is 2, I'm going to put the 2 here. I'm going to list the coefficients, like I'm setting up a synthetic division problem in decreasing order. So if it's 5x to the third, there's no x squared, so I have to put a 0x squared, 8x minus 7. I like to put the dashed line to indicate remainder. You don't need to, but I find it helpful. I'm going to bring down the 5. Okay, then I'm just going to work this out. Let's see, 2 times 5 is 10. 0 plus 10 is 10. 2 times 10 is 20. 8 plus 20 is 28. 2 times 8 is 56. Negative 7 plus 56 is 49. Okay, this remainder here is also the answer for when you evaluate f of 2. You would get 49. And it's kind of a cool trick, especially if you don't have a calculator, or if using the calculator would be more work than this. Okay, I'm going to do the same thing one more time, and this time I'm going to evaluate f of negative 1. Okay, so I want to evaluate f at negative 1. Okay, I'm going to go ahead and list the coefficients. 5x cubed, there's no x squared, 8x, negative 7. I like the remainder line, up to you. Bring down the 5. Negative 1 times 5 is negative 5, 0 and negative 5, negative 5. Negative 1 times negative 5 is positive 5, 13. Negative 1 times 13 is negative 13. So I get negative 20 as my remainder. And remember, that's the same as if I were to evaluate f of negative 1. And I should get negative 20. Plug negative 1 in your head into the original function. Check, you should get negative 20. Okay, we also use long division and synthetic division when we are trying to factor something completely and we know one or more of the factors. Now, as a reminder, the factor theorem is that a polynomial f of x has a factor x minus k if f of k equals 0. And that's because those mean the same thing. If it's a 0, it has a factor if I were to solve it. Okay, so in this case, they're going to give you a polynomial and they're going to give you one of the zeros. And then they want you to factor this completely, and then find all the real zeros. In the future, we'll find all the zeros, but for now, we're just going to find the real zeros. Okay, let's see. To start off, they told me that x is -5, which is a huge hint. Okay, because I know that x is -5, I'm going to divide that factor out of the polynomial, and then I can factor the remaining. You can use synthetic division, or you can use long division. Most people seem to like synthetic, so I'm going to use synthetic division, and they told me x equals -5, so it's kind of set up for that. Okay, I'm going to list the coefficients of the polynomial. 1x cubed, 3x squared, -18, -40. I like this. I'm going to bring down the 1. Now, because they told me that x is -5 is a 0, I should get a remainder of 0, and if I don't, then there's a mistake. Okay, -5 times 1 is -5, -2, -5, -2, +10, +40, 0. Okay, I got a remainder of 0. That's a good sign. That means that I correctly did this, or that the problem was correct. Okay, if I want to rewrite this as a polynomial, this is x squared minus 2x minus 8. Okay, now I'm going to go back and answer the question. Okay, it wants me to use the given solution to factor and find all real zeros. So I'm going to go ahead and factor as much as I can first. Okay, now let me think. Because they gave me x equals -5, then it must be true that x plus 5 is a factor. When I did the long division, when I divided by the first factor, I was left with this polynomial down here. So that's the remaining factoring I need to do. I'm going to keep going because I can now factor that other polynomial out more. Okay, what is this? 4 and 2. So x minus 4, x plus 2. Okay, now if they just asked me to factor, this would be my answer. This is fully factored for the real numbers. So read the directions because sometimes it'll ask you to factor, sometimes it'll ask you the zeros. In this case, it told me to factor and to find all real zeros. So that's fully factored. My zeros are -5, +4, and -2 by using the zero product property. Okay, this was a degree 3 polynomial. I expected to get 3 zeros, and I did get 3 zeros. Okay, we're going to try this one more time, and I'm going to fully factor x cubed plus 3x squared minus 11x minus 21. And I am going to find all the zeros. For this one, the first zero they give me is x equals -3 plus √2. Okay, -3 plus √2 is a little bit of a rough one to do with synthetic, but the nice thing about -3 plus √2 is because it has a radical component, this actually has a conjugate answer that always comes with it. So if -3 plus √2 is an answer, it is true that -3 minus √2 is also an answer. And if you think about it, if you solve by completing the square or something like that, we always do a plus or minus on the radical. So I actually have 2 of the zeros. I just need to find the third zero. Okay. I still don't want to do any kind of synthetic or long division with these 2 zeros, so I'm going to try to rethink this. Okay, I'm going to think of the factors that give me these 2 solutions, and I'm going to multiply them out so I can get a better polynomial to work with. Okay, so if my first answer was -3 plus √2, then it must be true that my factor is x plus 3 minus √2, because if I solve this, I would minus the 3 and add the √2. Okay, for the second factor, if I want to get -3 minus √2 as my answer, I must have had x plus 3 plus √2, so that when I solve it, I get -3 minus √2. Okay, I'm going to multiply this out. Okay, is this a lot of work? Yes, but if we keep in mind that this is a difference of squares, okay, those match, the other part's different, it makes it a little bit easier. Because if I do that, then it's x plus 3 squared minus √2 squared, which is just 2. Okay, I'm going to simplify this. Okay, so if I multiply them out, I get x squared plus 6x plus 7. That also means that if I were to set this equal to 0 and solve it, I should get these 2 answers. So if you're not confident in your multiplication, you could always solve that equation after you set it equal to 0 and then see if it in fact gives you the zeros you were expecting. Okay, now in this particular case, I'm going to do long division. because this is a nonlinear factor, but it is a factor. So I know that this is a factor, so I'm going to divide this into the original polynomial so I can get the remaining factor. Okay, and I am expecting to get a remainder of 0 because I did find that x squared plus 6x plus 7 produced the two zeros. Okay, again, look at x squared. Think about what you times x squared by to get x to the third. I'm going to get x. And I like to line it up under the like term column. You don't have to. Okay, I'm going to distribute x to the third plus 6x to the second plus 7x. Okay, just make sure that you are subtracting when you go down. You don't have to mark it again, but you do need to, in your head, recognize that, or it will mess up. X cubed minus x cubed, gone. 3x squared minus 6x squared is minus 3x squared. Minus 11x minus 7x is minus 18x. I'm going to bring down the minus 21. Okay, now we repeat. Okay, let's look. I have x squared times something to get negative 3x squared. So I'm going to need a minus 3. Distribute minus 3x squared minus 18x minus 21. Okay, and then remember I'm subtracting. Okay, cancels, cancels, cancels. Good. Remainder of 0 is a good sign because I'm trying to get the zeros. So if I divide out the zeros, I should get a 0. Okay, now I'm going to go back and answer the question. Okay, what was I trying to do? I'm trying to factor this and find all the zeros. Okay, so first I'm going to do the fully factored step. Let's see. So at the very beginning, I had two of my factors as x plus 3 minus root 2, x plus 3 plus root 2, oops. And then I just got x minus 3 when I divided those out. Okay, the original problem was set equal to 0, so I'm going to go ahead and maintain that format. Okay, this is factored completely. I have 3 factors for this degree 3 polynomial. Okay, and of course read the directions because sometimes they just want the zeros. They don't need it fully factored, in which case I wouldn't have had to do all of that. Okay, if they ask me for the zeros, what are the zeros? My zeros were x equals negative 3 plus or minus root 2. And then if I solve the new factor x minus 3, I would get positive 3 as my third zero. So I got 3 zeros for my degree 3 function, which seems reasonable.